Welcome to the next podcast on graphing. This time we're going to be looking at finding x-intercepts and getting an idea of how many turns can occur in a function. If I happen to be looking for x-intercepts of a function in a window like this on my calculator, and I see an x-intercept here and an x-intercept here, how do I know that outside the window the function doesn't turn back and give me another x-intercept out here where I can't see it because my window's not big enough? Well, if I knew that the function I was looking at could not turn a second time, then this turn would be impossible. So I would know that I had seen both x-intercepts and there weren't any more x-intercepts to see. So the first thing we're going to look at is a little rule for determining the maximum number of turns that a function can make. So let's go ahead and get right into that. I'll bring my calculator up. And what we're going to do is we're going to look at, well, let's see, I don't quite need it yet. What we're going to do is we're going to look at four different functions. Now, the degree of a function is the power of its highest power x term. In the first function here, there's only one x term. Its power is 1 understood because no power is showing. So we would say that this is of degree 1. In the second, and I left off some exponents here. In the second function, this is a function of degree 2 because this first x term has power 2, second x term has power 1 again, 1 understood, and so since the degree of a function is its highest power x term, this would be of degree 2. The third function again has a degree 1 understood term and a degree 3, so this would be a function of degree 3. And the last function has a degree 2 term and a degree 4 term, so we would say that this particular function has degree 4. So if you go back and review, this is a degree 1, a degree 2, a degree 3, and a degree 4. Now we're going to look at these functions and see how many turns they make. So let's go to the y equals for the inputs. Notice I've already input the second function, the third function, and the fourth function. I did that because they take a long time to input, and I didn't want to spend a lot of time doing this. But I want you to just look at the inputs just to make sure that you understand what the keystrokes are. Let's go ahead, though, and put in the first one because I didn't put it in. Notice there's a fraction in it, so I'm going to put the fraction in a bracket. So I'll say open, 1 divided by 2, or 1/2, closed. X, for which I use the xt theta key. You could use the alpha key followed by the store key, but xt theta is the easy way to do that, plus 1. Now, notice that the first equal sign is highlighted. The next three are not, so that means the calculator can see function number 1, but it can't see 2, 3, or 4. Now, to give me a quick graph, I'm just going to go zoom 6. That's going to give me a window of -10 to 10 on the x-axis and -10 to 10 on the y-axis. So zoom 6. And how many times does a degree 1 function turn? Zoom 6. So we're graphing a degree 1. It never turned. A degree 1 function has 0 terms. Now we're going to look at a degree 2 function. To do that, I'll have to highlight the equal on degree 2, so I arrow to the left. Arrow down to get onto the correct equal sign, hit enter. Now the calculator can see both of the first two functions. So the first one's degree 1, the second one's degree 2. Let's see how many times they turn. Zoom 6. A degree 1 turns 0 times, and a degree 2 turns 1 time. Let's take a look at degree 3. We'll go back to y equal. We'll have to let the calculator see our degree 3 function, so I arrow down, hit enter. Now it can see all three of them. Degree 1, because the power of x is 1. Degree 2, power of x is 2. And here, instead of saying cubed, I said to the power 3. Because that's easier to do than a cubed. So I'll hit zoom 6. Degree 1 function turns no times. Degree 2 function turns 1 time. And that was kind of quick, but the degree 3 function came down like this, made a turn, went up, made a second turn, and then appeared to shoot all the way down. Now let's go ahead and add the last one, a degree 4 function. Again, I'll arrow onto the equal sign and arrow down, enter, and I'll hit a zoom 6. Degree 1 function, 0 turns. Degree 2 function, 1 turn. Degree 3 function, 2 turns. And degree 4 function, yeah, I think you saw those 3 turns. Came down and made a big turn here, then a big sweeping turn here, another big turn here, and went up and away. So in each case, the number of turns was 1 less than the degree. Now that doesn't have to happen. It can be more than 1 less than the degree, but it will never be more turns than the degree minus 1. So I'm going to say the maximum number of turns of an nth degree function is n minus 1. So if it's degree 4 and you've seen it turn 3 times, it cannot turn again. Okay, let's go on to the next part. The next part is called finding x-intercepts. I've got a couple of functions here that I want to find the x-intercepts for. Notice how I've written the answer blocks here. I'm allowing for as many as 3. The number of solutions won't exceed the degree of the equation, so there may be as many as 3. But look what the y component is for every x-intercept. I've already written that in. The y component is 0. That's what you mean by an x-intercept. You mean a point on the graph where the y is 0. Because if the y is 0, you are on the x-axis. If you're above it, y will be positive. If you're below it, y will be negative. So if you're actually hitting the x-axis, y is going to be 0. So let's take a look at our first function. I've gone ahead and entered it here in the calculator. It's negative x plus 1 cubed. Again, for cubed I use the power 3, plus 3x plus 3. Now I don't want to look at those first 4 functions, so I'm going to arrow onto there and get rid of them. So I hit enter, down, enter, down, enter, down, enter. And now I'm not looking at the first 4. I go down to the 5th one, enter. I can see the fifth function, and I'm going to go ahead and give it a quick graph with a zoom 6. And you can see that it has 3 x-intercepts, one here, and one here. Right now your window is negative 10 to 10 on the x-axis, and what that means is that this is negative 10 and this is positive 10. It was also negative 10 to 10 on the y-axis, so this is negative 10 and this is positive 10. But look at the difference between the marks. Really crowded on the y-axis, nice spaces between them on the x-axis. This is because the graph is not as tall as it is wide. So if I'm trying to put 20 total units vertically, they kind of get smashed all together. So when you look at the standard window, your graph is really a little bit smashed in from top to bottom. Usually, though, that doesn't matter. We can see what's happening here. Now, suppose I wanted to know the y-intercept. If I've got a nice even window like this, the y comes up in the middle. And to see what that is, we could use what's called our trace feature. So I hit trace. And I need to get onto this curve, so I arrow up one to trace 5. And you can see a little tracing symbol right here that's flashing on and off. I'll move it a little more to the left so you can, to the right so you can see it better. I'll move it down here. There's the little tracing symbol. See it flashing there? So when we first came up, it was right on the y-axis because of the window going from negative 10 to 10. If it had gone from negative 5 to 10, this would not have come up on the y-axis. But it did, so when I hit the trace, I can see right here that x is 0, therefore I've got the y-intercept, y equals 2, so my y-intercept would be 0, 2. Now what we're interested in is x-intercepts. And you can see where it hits, and you can see that all the action is right here in the center. There's nothing going on out here, there's nothing going on out here. So I'd like to spread this out to get a little bit better view of it. So I'd like to start my graph about here, which would be negative 4, and end my graph about here, which would be positive 2. So I'm going to change my window. And I'm going to arrow down and say, instead of starting at negative 10, I'd rather start at negative 4. And I'd rather go to positive 2. And look how it really spreads the graph out then. Oh man, I get a much better look at those x-intercepts. Now, it doesn't matter which one you go for first. I just hit the trace. Hit the up arrow. There you can see it. Whoa! looks like we landed right where y is 0. Well, that's nice. So we got our first x-intercept. Our first x-intercept is, whoops, that's down here. Our first x-intercept is, let me look at it one more time, -1, 0. So I'll put in here -1, 0 for my first x-intercept. For the next x-intercept, I'm going to arrow over here to the left and see what that is. Again, we want y to be 0 if we're at an x-intercept. So right now y is -0.7. Now it's -0.4, so we're getting closer to 0. Now it's -0.05. That's really close. I would be willing to accept -2.72 as an x-intercept here. But I wanted to demonstrate to you the zoom in box feature, so I'm going to see if I can get even a little closer to y = 0, but that's pretty close right there. Now to do the zoom in box, what we're going to do is we're going to draw a little box right around the area of the graph that we're interested in. Boxes draw to the right and down, so we're going to want to start our box up and to the left. So I go to the zoom thing, I say zoom, and then zoom box is the first option, so I go 1. Now my big tracer's disappeared, and I've got this little tracer that looks kind of like a plus sign. I'll move it up so you can see it. See, the little tracer looks a little bit like a plus sign. I went up just 3 clicks. I'm going to move over 3 clicks to the left. Little hard to see it, but now I'm going to hit enter, and that's going to change the tracer into the shape of a box. May be hard for you to see, but now it looks like a little square box, and once it gets to that square box shape, you can then draw your box. You draw it to the right, so I'm going to go about 6 clicks right, and about 6 clicks down, and that puts the area that I want to look at, which is where I cross the y-axis. That puts it right in the middle of the box, and then I hit enter, and it'll blow it up and fill the whole screen. Now all we're looking at is what was in that little box. Remember, the last time the closest we could get to y = 0 was y equals -0.05, and -0.05, oh well, we're not on the trace yet. Trace, up, there we go, and there's our -0.05. Now we can get closer to 0. If I arrow 1 to the left, I'm at -0.03. Arrow 1 more over, I'm at -0.002. I'm really close to y = 0 now. That takes me away from y = 0, so I'm going to go back here. We said that we would agree to -2.72. It looks like -2.73 is a better choice. So I'll go, I don't even think I'll have room to put it in here. I didn't leave enough room. So I'll say -2.73 for that intercept. Well, that leaves us just one intercept to find. If we go back to zoom 6, we've found this intercept. That was at -1. We've found this intercept. That was at -2.73, and that's kind of what it looks like. Now we need to find this intercept. And I want to point out that there's a better, slicker, faster way to find intercepts. And I want to show you what it is. It involves something called second trace 5. I hit y =, and what I'm going to do is I'm going to get rid of this first function by hitting clear. I don't need it anymore. We're not going to graph that one anymore. And I'm going to replace it with this simple function y = 0. Now y = 0 is the x-axis. So when I graph this, 2 functions are going to graph. The cubic function that had 2 turns, this one here, number 5, and the y = 0, which is the x-axis. Now you be watching up here as the graph is made. As long as the little flashers here are coming on and off up here, it's graphing. So for a long period of time, nothing's going to happen to the graph, and that's because it's graphing the x-axis. Well, the x-axis is already there. So as it's graphing the x-axis, you're not going to see anything happen. So again, I'm going to hit zoom 6. And here goes the graphing, and you can see that it's just graphing away here, but nothing's happening because it was graphing the x-axis. And then it graphed the cubic function, function 5, and then that turned off. So right now there are two functions there. I'll show you with the trace. We'll hit trace and we'll go to the cubic function, and you can see the flasher up there on the cubic function, and the other function that's the x-axis. So watch when I hit arrow up, that'll drop down to the x-axis. See there? So those are the two functions. I can trace along the x-axis like this, or I can drop down and trace along the cubic function like this. See, there it is, tracing along the cubic function. Okay, now we need to determine this last intercept over here. We've already found that one. We already found that one. We're going to do this one by doing something called a second trace 5. It's like this. You'll hit the second key. You'll hit the key right underneath the graph called trace. And then you'll hit number 5, and I'll show you why after we do second trace. So we want to find this intercept. The first thing I do is I arrow over and get close to it. So there I'm pretty close to that last x-intercept. Then I hit second, trace, and number 5 says intersect. It tells you the points where two lines intersect. So if I could find the intersection of the x-axis with our curve, I would have my last intercept, because the intercept is that intersection with the x-axis. So I hit 5. That's why you hit a 5. And it says first curve, which is what's the first curve you want to look at. And remember, we're on the cubic curve right now, so that's the first curve, so we just hit enter. And then it says second curve. What curve do you want to look at now? So we just hit enter again. We're having trouble. We can't leave that first one, so I need to make an adjustment. Hold on a minute. I'm having a lot of trouble with the trace feature on the emulator here, so you kind of need to bear with me. We want to figure out now this last intercept, so I'm going to hit the trace, and I'm going to take it to function 5, and I'm going to trace over to where they cross, and I'm going to do my second trace 5. So second, trace, and then 5 is intersect, and it says what's the first curve, and I'm tracing along the curve 5 there, so that's my first one, so I say enter, or that was on the x-axis. Then the second one says curve 5, so I enter, and then it says guess. Now guess means get me close to where they cross. Well, you can see my tracer is close to where they cross, so I'm just going to hit enter again. And bingo, it calculates the point of intersection between the x-axis and the curve. Now, this E negative 13 just means this thing starts off 0.00000. So it didn't give me a perfect 0, but it's so close to perfect. It like leads with 12 zeros. So that's perfectly good. And 0.732 is our last x-intercept. So let me get rid of my calculator so I can put that in the box. Right there is 0.732. I just didn't leave myself enough room to get those in there. Okay, let's take a look now at our last function. Our last function is of degree 4. It may turn as many as 3 times, and it could have as many as four x-intercepts. So notice I've put 4 points down here with zeros, but that doesn't mean it will have 4. That just means it could have up to 4. So let's go ahead and bring it up. And we need to get that function entered. It's not entered anywhere. I don't want to deal with function 5 anymore, so I'm going to move down there and unselect number 5, and I'll go up to number 2 and put this last function into number 2. I hit clear to get rid of it. You have to really be careful when you hit clear. You see it in one punch, it eliminates the whole function. If you're just trying to eliminate a couple of symbols, hit delete, not clear. Okay, here's the function I have to put in, 0.014x to the 4th. So 0.014x to the power 4 minus 0.4x squared, 0.4x square key, and then minus 0.08. So I've got that function in. I'm going to hit the graph. Again, one of the things I'm going to be graphing though is y equals 0. So you're going to see the little graphing indicator going off over here while nothing's happening because it's graphing the x-axis, which is already there, so there's no new dots coming on. So I hit graph, graph. Now let's see, do I have the good window? I don't have a good window. I'm not going to hit graph, I'm going to hit zoom 6. Go back to a negative 10 to 10 window. So I'm graphing the x-axis. Now I graph the function. So we can see 3 x-intercepts, 1, 2, 3. The first x-intercept right here, we should see that when we trace. Should get y equals 0, so I'll hit trace. Ooh, and we don't get y equals 0, do we? Let's see. Let me go up. There we go. There we go. It says y equals negative 0.08. So that's telling us that this is actually below the axis and that we're not really getting an intercept here, if that's the highest point. But now there could be a higher point to the right or left. So if I want to make sure that there's no intercept there, I could do a zoom in box and see if the graph ever crosses the x-axis. So that's what I'm going to do. I'm going to hit the zoom key here. I'm going to go to the box, and I'm going to draw a little box right around this center area to see if the graph ever touches the x-axis. Because if it stays under it, we don't have any x-intercept there. So I'm going to move up. So first I've hit the zoom and I've hit the box. So I'm going to move up a little bit. I'll go up, I'll say 3 clicks. I'm going to move over about 4 or 5 clicks, because I want to see that whole area and make sure it never touches. And then I'm going to hit enter and watch the little plus change to a box. There, it's now a box. So now I go to the right about 8 or 10 clicks. That looks like enough. Then I go down below and I want to get a look at that, so I hit enter and it'll blow it up and fill the screen. Right now it's graphing the x-axis. Look at that. The function never does actually touch the x-axis, so there is not an intercept there. So sometimes on these graphing calculators it'll look like lines are touching, but that's because of the pixel size. When you take a really close view, a zoom boxed view, you can see the lines were never really touching at all. So let's go back to our original graph. Now we know there's just 2 intercepts. So we'll go zoom 6. That'll take us back to our original graph, negative 10 to 10. Right now it's graphing the x-axis, and we want to come out here and we want to find this first x-intercept. So I'm going to hit a trace, and I'm going to trace over to the right to get close to that first x-intercept. I'm on the function number 2. Now I'm kind of close to it, and so I want to do my second trace 5. So I go second, trace, 5. And that's going to find a point intersection, and it says, what's the first curve? Well, the one that we're on here is curve 1. So I hit enter, and I want to see how that intersects with curve 2. So I hit enter. It says, give me a guess. Well, I'm already close to the cross point, so I hit enter again. And it tells me that when y is 0, x is 5.36. So I'll put in 5.360. Now my suspicion is the other one is negative 5.36, because that looks like a symmetric graph. It looks like if you fold it on the y, this part would just lay right onto that part. But let's not guess about it. Let's get over there. So I'll trace over to the other function. Let me hit my trace key again. I'll trace over to that other function. Over to that other intercept, I should say. Get kind of close to it. There, that's kind of close to it. I'll do a second trace 5. And it says, what's the first curve? I hit enter. What's the second curve? I hit enter. And then it says, give me a guess. Again, that means get your little tracer very close to where they cross. Well, the tracer is close to where they cross. So I hit enter again. And it says my second x-intercept is at negative 5.36, which is what we thought it was going to be. I don't want to crowd that in, so I'll just say negative 5.36. Now you could see that we did not have two more intercepts, so I'll just erase those. And even the center one, which might have given us a third intercept, that turned out that wasn't an intercept either. So we just had two solutions there. That completes our podcast.